Welcome to the CS1033 Programming Fundamentals lecture series, lecture on data structures with tuples and sets. We have completed our discussion on the very important data structure called list, and next we will look at the tuples and sets. So as per the content, first I will discuss tuples, discussing how to create tuples, what are the operations available on tuples, and the comprehensive set of built-in functions provided by Python for working with tuples. And similarly, in the second half, I will discuss the sets and how to create them, what are the operations available, and the set of built-in functions that we have from Python. Okay, so tuple is defined as a finite ordered list of elements. Okay, so the conventional sense is that we have this ordered set named by the number of elements. Okay, so if we have n elements, we call it n tuple. So a 4-element tuple or a 5-element tuple, like that. But we have some special names for special tuples. Okay, so a tuple with no elements also exist. Okay, so that is the zero tuple. Okay, we call it null tuple or empty tuple. Okay, and a tuple with a single element exists. We call that a singleton or a single tuple. And more familiar tuple we have is the tuple with two values or two elements, which we call the two tuple or a couple or an ordered pair. Okay, so I have highlighted the more widely used names here, like null tuple, singleton, couple, or in the case of a 3-tuple, which is a triplet or a triple. Or okay, so these are the more widely used names. But in general, we can indicate the number of elements n and write as n tuple. So in the Python programming language, tuples are created as a sequence of comma separated values. Okay, and the values, these comma separated values can be optionally grouped using parentheses. Okay, so very often we use the parentheses because then visually it is very clear to us what we have here is a tuple. Okay, so let's see the different ways in which we can create tuples in Python. So we can create the empty tuple or the null tuple by simply using the brackets. Okay, obviously there is no other way to indicate it. We can't just leave empty space there. Okay, and then we can create a triple here, for example, by listing 3 values separated by commas, and the brackets here are actually optional. Okay, but in general we use them. I think as a good programming practice you should use them. We can also use the tuple function provided by Python to create a tuple where we would pass the argument. Okay, so here the argument taken by this function is a string. Okay, and from that string elements will be extracted. So we'll see in the runtime how the tuple will be created. Okay, and we can use a list and pass that list to the tuple function again. What we need to pass is actually an iterable collection. Okay, so a string is iterable collection, a list is also iterable collection, as we have just discussed. Okay, and the tuples can contain any number of elements. So, depend on the number of elements n, we will call it the n tuple, and each element can be of any data type. Okay, so there is no requirement for homogeneity that all elements in a tuple must be of the same type. In fact, the usefulness of tuples come from the fact that you can have different type of elements paired in that manner. You can see here we have tuple 1, which is a day and an integer value and a string, and a tuple 2, which is another string and an integer. Now, mind you, these are two different types of tuples, okay, because the order in which the value types appear is important to define the type. Okay, so while both contain similar values, integer and a string, these are two different type of tuples. Okay, both are pairs, but the type of the tuple is different. And of course, you can create tuples using tuples. So as we have shown here in line number 16. Now, the Python interpreter must be made aware that you are working with a tuple. Okay, so so if you simply put only brackets, it will not know that you are dealing with a tuple. So so if you have one element, it is not sufficient to say that it is a tuple. Okay, so so mind you, because as I said, these brackets are optional. So just think for a second. If you have the same line 18 without the brackets, then this would be actually where you are declaring a string. Okay, you are just declaring a string. So to make sure that this is actually a tuple, you have to put a comma. Okay, you have to put a comma. So as you can see now, it is quite clear what you are dealing with is a tuple. Okay, and so in this particular line, you are saying this is a tuple, but it has only a single element. And in the next line 22, we have the use of the repetition operator. Mind you, we introduced this repetition operator in the list data structure, and essentially what we are doing here is repeating this particular singleton. So this is a singleton, a single element tuple, a singleton 3 times. Okay. Let's see what we get as output in these different scenarios. So as you can see, we have the empty tuple initially in line number 1, and then we have created a tuple using strings. So that's a triple or a triplet. And when we pass a string to the tuple method, the built-in tuple function to create tuple, you can see that string, which is an iterable, has been iterated and individual elements extracted as C, S, and E, and a triple has been created. Then you can see when we pass a list, which is again an iterable, a 4-element tuple has been created as 1032, and so on and so forth. So you can see that when I created a tuple 3 using 2 tuples, it is actually a pair. Okay, it's a pair of tuples, and each element in that pair of tuple consists of a pair of integer value and a string value. And as you can see, I have printed on line number 19 what happens when I declare a tuple without a comma. So then it gets printed as test, just a test, which is actually a string. And then when I put a comma, it gets printed as a tuple. Now you can see when the printer, the Python would print it with brackets on either side, indicating it is a singleton. And by using the repetition operator, I have repeated the singleton 3 times and created a tuple with 3 elements for a triple. Moving forward, let's look at the accessing of elements within a tuple. Tuples are immutable, okay? But that means after creating a tuple, you cannot change its values. So this is quite different from, say, for example, the list. After creating the list, we can change it. As we have seen, the sequence of elements in a tuple are of different types. Okay, so mind you, in a list also the elements are heterogeneous, but very rarely we actually do it that way. So a list is normally a homogeneous collection of items. In contrast, normally a tuple is a heterogeneous collection of items. There are 2 ways of accessing these elements. One is called unpacking, other one is called indexing. I have noted here for your reference how the tuple differs from its behavior with respect to lists. Okay. So let's look at some sample code. Here, first of all, I am showing the access of the tuple through indexing. Okay, using indexing. So indexing allows us individual allows us to access individual elements. Just like in the other iterables, like the list, the first element is indexed by 0, second element indexed by 1, and so on and so forth, up to, if you have n elements, the last one would be n-1. So that is how you access them individually through the indexing. We can also unpack the tuples if we know correctly how many elements are in the tuple. We can write these unpacking statements. Here I have given ABC 3 variables indicating that they form a tuple, and on the right hand side I have the variable tuple. Now each element, corresponding element, will get assigned to the variable. So A will be tuple 0, B will be tuple index 1, C will be tuple index 2, and if I print, I will get the correct value assignment. So to do this, of course, you must make sure that the unpacking can be done correctly with the left hand side having the correct number of variables. Okay? Otherwise, there will be an error. Another very useful feature of a tuple is that you can do swapping of elements quite easily, especially because of this unpacking. capability we have for the tuples. Okay, so here I have two strings, A and B, and you can see I have printed it as a tuple here. Okay, tuple here, AB. Okay, and now I can create. Mind you, A and B are individual variables. Okay, they are individual. I don't actually have a variable tuple here. Okay, I haven't declared a variable tuple as earlier. So for example, here I have the variable called capital T tuple is a variable of type a tuple variable. Here what I have is A and B, which are just strings. Okay, now I can swap the values of A and B by treating them as a tuple. So what I'm saying here is, on my left hand side in line number 4, I have a tuple AB, which are variables actually. Now A is a variable, B is a variable, and on the right hand side I have the tuple representation of the variables A and B again, and the notation here states take the value in variable B. Okay, take the value in variable B and assign it to variable A, and take the value in variable A and assign it to variable B. Okay, so as you know, normally when we want to do a swap, first of all, we will have to store the value of A into a temporary variable, then assign B to A, and then assign the temporarily stored value to B. Otherwise, we lose the value A, no? Because if we directly assign the value of B to A, the value in A will be lost. Okay, so when we do it, we have to actually use a temporary holding variable. But using the tuple capability, we can do the swapping very efficiently. Okay, so internally in the Python runtime system, of course, it uses a temporary variable, but it is done by Python built-in function capability. So it is much faster than us writing a swap function ourselves and using a temporary variable. Okay, so yeah, so this is actually a very widely used Python capability for swapping of values. So I have below the output when you run this code. Okay, so you can copy the code from the slides and put it into a Python interpreter and run and see. Mind you, I'm using this LaTeX for creating slides. So you will have to replace all these single quotations with the straight quotation in your keyboard. The character is normally next to the enter key, to the left of the enter key. So this one is the right angle quotation, and there is a left angle quotation. So you should not, you can't use this one for your you can't run it with your Python interpreter. Okay, make that change when you execute the sample code. And we can use the plus operator for concatenation, like what we have seen for lists. So essentially, you will be creating a new tuple by adding the second tuple to the first tuple. Okay, because addition is a binary operator, so you will have one operand on the left side and another operand on the right side, and the right hand side operand will get added to the left hand side operand. Okay, so that's how it will work when you use the plus operator. Okay, let me show you the sample code. So the tuple, the first tuple is a triplet, true, false, true, and the second one is a triplet 1, 2, 3. And if you just add it, you get a 6 tuple, 6 tuple, a 6 element tuple. Okay, 6 element tuple. And then you can see in the next example, I have a tuple 3, which consists of 2 tuples within that. So if I add tuple 2 and tuple 3, that will be a 5 element tuple, 1, 2, 3, 3 elements, and then the fourth element is this tuple with 2 values 4, 5, and the fifth element is the tuple with the pair 6 and 7. Okay, so that's how it becomes a 5 element tuple. Just like in list, we can do slicing of tuples also. Okay. And I have here examples showing how we will do that, because in a manner similar to a list where we can access elements by indexing, we can do similar slicing of tuples. Okay. Let's check this with our example code. So we have the string CS1033 PF. Okay, so actually that is your postcode. So I'm sending this string to the tuple function, built-in function, and then the tuple function will iterate over this string and will create a tuple with 1, 2, 3, 4, 5, 6, 7, 8. 8 elements. So that will be an 8 element tuple. And then in this first line, I am slicing the tuple from beginning to the second element. Okay. So, so as you know, when we do the slicing notation, when we leave it empty here, that means it is the first element. So this will have the elements at addresses 0, 1, and 1, because this is 0, 1, and it will be up to 2, not including 2, so 0 and 1. So that is how you get the course. So this is how the course code is actually defined. CS, the first 2 letters define what is the department offering it. So CSC, Computer Science Engineering. And then we have the short name of the course, Programming Fundamentals, given from the sixth element onwards. So this is the 6th element, or address location 5. So it depending on the particular module name, it will have whatever the length. So I can say, like, take the short name starting from 6 until the end. So I don't define the end. So the blank would mean this is the end. So in this case, I get a tuple P and F, and the ID number for a course is the code that is given from 3, 4, 5, 6. This the locations 3, 4, 5, 6. So so I have so the address would be, starting address would be 2, because we start with the address 0, address location 0. So I'm asking for the ID number to be taken from 2, 3, 4, 5, okay, up to 6, not including 6. So that gives the code. So you can see the splicing is very convenient. If you have a tuple, you can slice it to different parts and use it for whatever the purpose you want to use it for. Similar to the positive values, and similar to what we do with lists, we can use negative values also. Okay, so in that case, we will be starting from the end. Okay, so then of course, if you take the course, the starting address is 6 and then going backward. Okay, so it is indicated by the negative value and starting from that value to the start of the tuple. And similar to that, we can define negative values to get different parts of the tuple. So starting from the end, go back 2 elements to get the short name. So as you can see, this is not good way of getting the short name, because this will work if the code if the short name is only 2 characters. So it could be more than 2 characters for the short name. Okay, so in that scenario, this is much better, because up to this particular location, this is fixed. 2 characters for the department, 4 characters for the course code, and thereafter any number of characters for the short name. So that is nicely captured here by saying go from 6th onwards to the end. Yeah, but this is just to showcase the use of negative indexing. Okay, and we can get the ID number by giving a range here, starting from 2 from the end up to the 6th one from the end. Okay, negative indicates starting from the end. Right. Okay, so to delete a tuple, as I said, tuples are immutable, so we cannot delete a part of a tuple. Okay, we have seen how we can delete part of a list. Okay, so it was very useful actually. So we could just delete a selected part of a list, but you can't do that with the tuple. If you use delete statement on tuple, the entire tuple gets deleted. Okay, so if you try to print a deleted tuple, it will give you an error. So I am showing it here. So we have the tuple here, and I am using line number 3 to delete it. Okay, after deleting, I try to print it, and then I get an error message saying line number 4, you are trying to print a tuple, whereas it is not defined, which means Python system has removed that particular variable because you deleted it. Okay, right. So similar to the list, Python also has a significant set of built-in functions which are very useful. Right. So this is the summary list of those functions which behave in the same manner as for the list. Okay. So we have discussed these functions for the list, and the same discussion is applicable for the tuples also, because tuples are also iterable. So if you remember, when discussing the list data structure, I kept saying iterable. Okay, iterable, and then saying the iterable here is list. So I'm not going to discuss any of these again, because the same discussion is applicable. So for example, all behaves in the logical AND function or logical AND statement. Any behaves in the logical OR statement, and we can enumerate so that if we have a tuple, we can give a value to each of the items. So when you enumerate, it will say the 0th element is the first one, first element is the next one, like that. So you can get a list with the index value pair. Okay, index is position in the particular tuple. And then similar to that, length will give the length, the number of elements in the tuple actually is the length. Okay, number of elements. So if you have a tuple with values where the values have a meaning when you ask for the maximum value, then passing tuple to a max will return you the maximum value. Of course, now remember, there must be a meaningful set of values in the tuple for you to get this. Similarly, you can get the minimum value. So this is quite applicable if you have a tuple of integers, tuple of real values, tuple of strings, tuple of characters, like that. Okay, because they do have an order. Then similar to the list, you can sort a tuple. So the elements will get sorted in the indexed order, 0, 1, 2, like that. So they get rearranged within the tuple. They get the positions get rearranged, and yeah. So if these tuple, if a tuple contains numbers as values, you can use the function sum to get a summation. Okay. So I have one screenshot of the execution of these built-in functions, showing you how they actually work. So for example, I have a tuple with 3 values: true, false, true. Okay. Now if I apply that tuple to the function all, it will return to me true only if all the values are true. So as you can see, one value is false. So what should get returned is false. And if I send the same one to any, the function any, if even one value is true, it will return true, which is the case here. Okay. So you should actually pass tuple with all values true and all values false to these two and see what happens. And then in the second tuple, I have this set of values, tuples with the integer values. And if I use enumeration, it will give me each value with a corresponding index like this. Okay. And use the other values like length, maximum, minimum, and the summation. Okay. And if I sort it, I will get the values in the tuple return to me as a list. Okay, return to me as a list in sorted order. Okay, so mind you, the tuple remains as it is. Okay, tuple remains as it is. So if you print the tuple again, you will get the same tuple printed. Okay, so you will get this this particular output if you print the tuple 2 again. But it will return to you a list. As you can see, the square brackets at the two end indicate that this is a list and it's comma separated set of values which are in the correct order. Right. So our this part of the lecture series is concerned about solving problems. So what are the practical uses of a tuple? Okay. Now the obvious one that would come to your mind is representing Cartesian coordinates. Okay, we are engineers. Whatever the field of engineering we are going to practice, say civil engineering, mechanical engineering, or chemical and process engineering, you will require Cartesian representation of data. It could be a structure, it could be a machine element, it could be a chemical structure, whatever it is that you will require Cartesian representation. Okay, it could be 2-dimensional, 3-dimensional, or depending on the application type, it could be higher dimensional. So we would be naturally using tuples for such Cartesian coordinate representation. Okay, so that's one common and wide use of tuples. Next one is using tuples as records in a database. So I would say tuples are used even more often than lists. Okay, so list is a widely used data structure to solve all kind of problems, because we want to maintain our data in list structures while we try to solve the problem. But if you have large amount of data, you would put them into a database. Database is essentially a collection of data records, and a data record is a tuple. Okay, so we suppose I have example here. So I want to create a database of Intel processors and store some information. So if you look at the new Intel processor series, each processor has a name like i9, i7, like that, and then there is a number. So the number generate. So the I stands for Intel. The next number stands for a particular product line. So if you take, for example, i3, that is essentially for low-end laptops and tabs. i9 is for high-end desktops and workstations. i7 is for high-end laptops, and i5 is for mid-range laptops. It's like that. Okay, so these are product ranges that that Intel is creating. So obviously i3 is the cheapest and i9 is the most expensive. Then you have a code. Here the first number tells you the generation. So 8th generation, 9th generation, like that. So right now I think this 11th generation is the more widely available one. If I'm buying a laptop, I'll buy a 10th generation one because the price is cheaper and the performance is only slightly less. And then there are other numbers to indicate the particular release, and letters to indicate specific types. This is the basically, given a processor, this is the processor ID. Okay, and for each processor, the model, it will have different number of processor cores, and it will have a particular speed given in frequency value of gigahertz. And it has an internal cache, which we call the level 3 cache, given in megabytes, and they get released in specific years. Okay, so if I want to store all this data, because this is actually a collection of data items, a string, and then some an integer, real value, and then a couple of other integers. Okay, so of course this is a year. And it is our interpretation that it's a year, but it's an integer value. Okay, so what I have done here is I have created a database actually. Okay, and the database consists of a list of values, and each value contains a specific data item. Okay, specific data item. Right? So you can see that, for example, here I have used this database to give a print out the year in which each processor is released. Okay, so let me show you that output here. So different processors are releasing different years. So like if you are going to buy a laptop and you want to buy the latest one, so you would want to know in which year the processor in that particular laptop is released. Okay, so you can see, I'm just giving an idea to you here. So this would be a more expensive laptop. It's an i9 if it is a laptop. Okay, yeah, generally it would be a desktop. But this one is i3, it's a cheaper version. Okay, but it is more recent. It is released in 2019. So so we may want to maintain this kind of data, and we can one straightforward way of managing this kind of data is as in a database. Okay, so so you will have various problems as engineers where you will have to store data and use it repeatedly for various problem solving, and the convenient way is to manage such data as database entries. Now let's move on to the next data type, sets. A set is actually considered the basic mathematical construct. Okay, so if you ask what is the most basic mathematical construct, that is a set. Okay, so you should read on the history of mathematics. There are various interesting articles and books available, and you will understand that set is the fundamental mathematical construct. So in Python, we have a data structure which represent this basic mathematical structure. So it is essentially a collection of distinct objects. So in a set, you have these properties. It is unordered. So the elements or the values in a set don't have a particular order. Okay, so you can't ask for the first element in the set. Does not make any sense. Last element or the third element, there is no such thing. But it is iterable. You can say, give me an element, give me another element, give me another element. So you can actually iterate one by one. So say you have a set of 4 elements and you ask, say the set of 4 elements are integers 1, 2, 3, 4. So you say, give me an element, you will get maybe 3. Then you say, give me another one, you will get 4. Then you say, give me another one, you will get 1. And then you say, give me another one, you will get 2. Okay. So that way, when you iterate, you get 3, 4, 1, 2. So let's say you repeat it again. You say, give me an element. You might get the first one now, 1. Next time, next element, you will get the 4th one. And next one, 3. And next one, 2. So you can see, every time you run a iterator on a set, you will get in them the elements in different order. Okay, conceptually. Of course, when you write a program and do this, you will see sometimes it doesn't come out in that kind of random order because of the way we store values. However, conceptually, it is unordered, so you should not expect to have the same order repeated when you access data values in a set. And also, you can change the values in a set, okay, similar to a list. And every value is unique. There are no duplicates. So if you try to put a duplicate value to a set, nothing will happen actually. So you put a duplicate, but no, it's like nothing happened. So it won't get duplicated inside. So the cardinality of a set is the number of elements in the set. We have a built-in function length, len, that gives us the number of elements in the set. So how do we create a set? We do that by using the curly bracket to indicate our iterable collection and putting individual elements separated by commas. That's one way. Other one is we have a built-in function called set, to which we can pass a list or a string, basically an iterable collection. Okay. The important thing to remember with sets is you can change the values in a set because it's mutable, but any elements inside are not mutable. Okay, so we'll see that in examples here. So when you are creating a set, using the built-in function set, you cannot have inside the set. So you have, so this you are, so within this is your set. Okay, let me have a better diagram. Okay, so inside here you have the set. Okay, so you have the set. Let me indicate that. So this is your set. So you have various elements inside the set. So these are your set elements. Now, these elements, what you have inside, they cannot be mutable by themselves. Okay, they cannot be mutable. The set is mutable, but not the elements within the set. So, so as an element, you cannot put a item like a list, because that can be changed, or a set, because that can be changed. Or there are other, we'll discuss other composite data structures like dictionaries. Okay, so they cannot be elements. So the elements in a set is heterogeneous, just like what we had for the tuple or the list. So they can be of different data types. However, each item has to be unique. Okay, so when you are creating a set, you can pass duplicate items. There's no problem. Python will handle it correctly. Okay, so if you keep sending the same element to the set to be stored, it will accept it, check whether it is already there. If it is there, it will ignore it. If it is not there, it will add to it, because the set is mutable. It can keep on growing, or it can keep on shrinking. So I have some example code here to show the creation of sets with Python. So we can create an empty set by calling the set built-in function without any arguments, or using the curly brackets without any items inside. Okay, both are basically giving us empty sets. If I pass a string to the built-in function set, the string is iterable. It will get iterated element by element, and a set will be created because there is no order. Yeah, it's been shown on alphabetical order. Okay, and if I pass the string as a list of values, character values or string values, then it will create a similar set. And here I have another one, the CS1033 S1, like that. So this is because I made the lecture notes originally for the last, this screenshot for the last year. That's why this code is 3.2 and the year is 2020. Yeah, that's but this is a string values. Okay. So if you give them as a list of strings, it will create a set of strings. Okay. However, if you give a string like computer science, okay, it will give you a set of characters, and you can see, for example, now E appears 3 times here, E in computer and science. Okay, but here E appears only once. Okay, so you can give a string with duplicate letters, but in this created set there won't be any duplication. Okay, for example, C, you have computer, there's C, and then there's C in science twice, so there are 3 C's, but you can see it's only appearing 1 time. And I have shown that with a set of integer values also. Okay, so the set with the duplicates would be the so when we so you can see I have this set 1 given in this manner, where I have passed a list of values 2984202017. So 2 is duplicate multiple times, 0 is duplicate multiple times. Okay, and so when I print the set, it will be printed without the duplicates. Okay, 0 is only appearing once, 2 is only appearing once, like that. Okay, whereas so here I have done the same thing without using the built-in function set, but using simply the curly brackets and comma separated values. Again, I am using 1 and 2 repeatedly, but when you print it, it will correctly print by removing the duplicates. Okay. Very useful. So let's look at some built-in functions we have here for the set. So the add function allows you to add 1 element at a time to a set. So because these are the set is mutable, we can do this. But remember, as I said earlier, you cannot add any mutable values to the set. Okay, the values you add must be values that cannot be changed. Okay, oh, they should be immutable. So as we discussed, tuples are immutable. So we can add them to a list. Okay. So here I have example code which shows what happens when you do addition. So here we have initially an empty set, and then we add the single element, and then we keep on adding elements and they get added. Okay, so we can add a tuple also. Right. So that add allows us to add 1 element at a time, but say we want to add multiple elements in one go, so we can use the update method. So in the update method, we have to provide a iterable. Okay, for example, a list. This is an iterable. So we can provide any other similar iterable which is containing immutables as its elements. Okay, so of course these are just integer values, so therefore they are immutables. The string again is an iterable collection of immutable values of characters, so they will get iterated and properly added to the set. So you can see that is what happens. So I give a list and they get added. Okay, and yeah, these heterogeneous data structure. So you have characters as well as integer values. Yes, so yeah, I must explain this to you. So I am adding a tuple here. Okay, tuple is also an iterable. So what happens is the tuple gets added by iteration. So it is not the entire tuple gets added. Okay, what gets added is the tuple iterated. So now the Python set update method will iterate through the tuple one by one in the elements and keep on adding elements. So it will add 20, as you can see, and then it will add the next 20. Of course, it's a duplicate, so nothing happens. Okay, right. Yeah. So yeah. So these are the things you must be careful with. For example, in the exam, you will be given a sample code like this, and you will be asked, okay, at the end, what are the values that are what is getting printed on screen, for example, and you will have 0, 1, 2, 3 CSC with 20, 0, 1, 2, 3 ESC with 2020 given as a tuple, like that. No, you will have 5 values. If you haven't studied this carefully, and if you haven't tried out your own code on the Python interpreter, then you will not be thorough with this. So you must, as I mentioned earlier also, run these example codes yourself and get a thorough understanding how it behaves. Let's look at accessing of elements in a set. So as we discussed, items in a set are unordered, so there is no indexing you can use. Okay, there is no indexing available, so we have to rely on iteration. Okay, so to iterate, we can use the membership. This is actually an operator. This allows us to check for set membership. Okay, so these are the 2 ways in which we can do it. Okay, so I can simply iterate because the set is an iterable collection. I can simply say for and I can use a control variable if necessary, but for the length of the len length and give the set variable as the argument, and then I can print or assign the values from the set, because every time I go through the iterator, I will get the next value and next value, like that. Okay, and other thing is I can use the set membership test by using the in operator or the in keyword. Okay, so as you can see here, I have a control variable here, I, and I'm going to iterate, because this for loop is for iteration, iterate through this iterable collection. So set 1 has to be an iterable collection. It is an iterable collection because it's a set, and you can see I will whenever I go through the loop, I will get the next element from the iterable collection. Okay. And I can specifically check whether a particular value is in the set. Okay, so this checking for set membership. Okay, so this has to be a value which appears in the set for it to return true. If it does not appear, it will return false. So in is a operator that, or it's an operator which returns a Boolean value of true or false. Here's at the example of running that code. So 5 is there in the particular set. So if you do the set membership test, it will return as true. We have 4 different ways in which we can remove elements from a set. We can use the built-in function remove. Okay. So to remove element from the set, we have to specify what we want to remove. So if the element is present, it will get removed. If it is not present, I'm sorry, I see a typing error. This should be present. Okay, present. There's an N missing here. I'll do a correction. It will generate an error. Second one is using the function discard. So you say what is the element you want to remove. If it is present, it will get removed. But if it is not present, no error is generated. So that's the difference between remove and discard. Okay. So both will do the same functionality, but remove will generate an error if the element is not there. Discard will not generate the error. You can use the pop function also to remove an element. So again, I see typing error. So we do not have a control what gets removed. So if you say pop, okay, let me go back to this particular set 1, 2, 3, 4, 5, 6, 7, 8. If you call pop on set 1, some element will get removed. We don't know which one. We can't be sure which one. Okay, right? So remember that. So if you just want to remove an item, yeah, just pop it. Okay. So I should make a note to make a correction in slide number 30. And the fourth way of removing element is use the function clear. Now clear will empty out the set. So it will remove all the elements that are in the set. Okay, essentially you ultimately end up with an empty set. So I have sample code here to show what happens. You should run the code and see so I have defined a set 1, 2, 3, 4, 5, 6, 7, 4, 3, 1. Of course, I have repeated some elements 3, 1, for example, or 4. But as you know, the set does not have any of these repeated elements. So when I remove elements, they will get removed. You should try out this example with the 2 methods, remove and discard, where you say you try to remove 11 and see what happens. And you try to remove 11 with discard and see what happens. Okay. So that way you will know what is whether an error is getting generated and what the error says. Is the error saying no value present or some indexing error? So it can't be an indexing error because sets don't have indexes. Set elements are not stored by an index. Okay, so carefully check what the error is. We have a copy function all available for set. So this allows us to create a shallow copy. Now you are familiar with this concept of a shallow copy. So let's see how that happens. So if you call the copy function on a set and assign, you will get a new copy. So the original set will not be changed. It will remain unchanged. So this is different from direct assignment of a variable, because if you directly assign to a variable, say you have a set variable and you assign it to another set variable, and then you change the original variable, sorry about the interruption. So if you have a set and if you assign this set to another set, and if you now make a change to the original set, yeah. So if you add an element to the set, and so you do some other operations, add, remove, all kind of operations, and then finally if you do these additions and removals to S1, okay, leaving S2 aside, but finally when you go and check on S2, if you print S2, you will find that all the changes you have made are reflected there. Okay, so that is what's been explained here. If you use the assignment operator, this one, any changes will be reflected on the original. Okay, so let me, yeah. So here's the changes being shown here. So set 1 is what? So set 1, I make a copy, and then the set 2 is updated, and you can see original remains unchanged. Okay, so I gave the opposite example in the previous slide. We have the set of set operations available in Python as built-in functions. So the first one I want to discuss is union. So it will be called by one set on another set, and the outcome will be the union of all the elements. So you are familiar with actually set operations, so I am not going to discuss that. This shows the Venn diagram scenario. So all the elements in A and all the elements in B will be in the final set. And the duplicates will be removed. Okay, duplicates will be removed. So you can see, yeah. So so you will have only one copy of things that appear here. Okay? Only one copy. So there are there are two ways in which you can achieve this outcome. So you can call the method on A by passing B, the other set, as the argument using the union, or you can use the operator. Okay. In addition to that, you can, when you use the function, okay, this you can't do with the operator. This operator is a binary operator. Union operator is a binary operator. But if you use the union method, you can pass multiple sets. Okay, you can pass multiple sets, and get the union. If you look at the output, any duplicated letters are removed. Any duplicate values are also removed when you look at the final set. Then we have the built-in function difference. So as you are aware that in set operations, the difference will give you the values from this marked area. Okay. So the result is essentially all the elements present in A, if this is the A, that are not present in B. So I'm taking the other set as B. Okay. Again, you can use either the built-in function difference or the operator minus. Now, this operator is again a binary operator, so you can only have the two you can have just the two operands here. Okay. Now there is an important behavior I want to discuss with you. If you look at, let me show you the runtime here. Okay, so you have A as computer, B as science, and so here COMPUTR. So there are no repeated characters there, but when we take the difference, any characters that appear here will get removed. For example, C will get removed. Okay, C will get removed. So so that's why in the set difference, C is not here, not present in this particular set. Okay, and E is present in the second one, so E is not present in the output. We have set subtraction, which does a similar outcome. Okay, and in the fifth line, I have this method called a difference update. A difference update. So now what happens is when you call the method a dot difference b, you are returned a result. You are returned a set as a result. A is not changed, so you should run this code and see whether A gets changed. A doesn't get changed. That's why after running this command, when I run this command, A is still the original A. Okay, so when I run the method difference, I am returned a set as the result. But if I call the method difference update, what happens is no result is returned. So you can see for the line number 5, I don't get anything returned. Okay, so when I try to print, nothing is printed, none. Okay, but if I now print the set A, you can see it has been updated. So that is the difference update behavior. Okay, it is called an in situ operation, which means the variable is affected right then and there in situ. It just no, the variable is updated. Okay, so remember this particular behavior difference for the particular method call. Then we have the intersection as another set operation. So all the elements common to the two arguments are given as the result set. So we can either use the built-in function or we can use the operator. So that operator is the ampersand operator, which gives you the intersection. So here's a sample code again, and similar to the difference, intersection also has an in situ version, which is intersection update, which will change the variable that you are passing. Okay, so yeah, as I said earlier, for these functions, if you for these set operations, if you use the built-in function, you can pass multiple arguments. Okay. So as you can see here again, if I do the if I use the method call, I will be returned a set as the result. If I use intersection update version, no result is returned, but the variable itself is updated. As you can see here, the variable itself is updated. Next, we can have the symmetric difference as another set operation. Here, all the elements are returned which are not common to both. Okay, so what is marked in red is what you get returned as a set. So I have example code for that. Symmetric difference has both a built-in function called symmetric difference as well as an operator, which is this this hat. Okay, this particular symbol which is available. Okay, so normally in the keyboard it is above the 6, the numeral 6, which we call the hat symbol, hat. Okay, so it also has an update variant where it will do an in situ change. Okay. I have the example of running that for you to try out. Then there are other methods available to test out the set properties. Okay, so we can give as input 2 sets and see whether their intersection is null. Okay, whether the 2 sets are disjoint. So these are mathematical concepts you are already very much familiar with. So Python provides direct built-in functions to test this. Now you can write your own functions using the basic set operations to implement this. In fact, you should do that as exercises to learn how to implement this kind of built-in functions yourself. But if you are writing code for some application, you would be better served by using the Python built-in functions because they run much faster. So this is the disjoint built-in function, and as I have explained here, this particular behavior can be obtained by simply checking whether the intersection, okay, this is the intersection, whether the intersection has any elements. So if you take the intersection of 2 sets and the number of elements in the intersection is 0, what does that mean? Well, they don't have any common elements, so they are disjoint. So you can return that as the Boolean value. Okay, so yeah. So the question is, okay, which one is faster? So because disjoint is a built-in function, it is faster. Here you are essentially using 2 built-in functions. One is the ampersand operator, okay, 1, then length, the element counting operation, built-in function. So here you are using two built-in functions and then doing your own basic operation, whereas this one is a direct Python implementation. So it should run faster. Similarly, we have the is subset. That allows you to test whether the given set is a subset of another set. You can actually check whether it is a so if you use the built-in function, it will tell you whether it is a subset or not. If you want to check whether a set is a subset or a proper subset, then you will have to use the operators. Okay, so I have given here the built-in functions as well as the operators you can use. So if you are only checking whether given set is a subset of the other set, you can use the operator, and it will be only slightly slower. Okay, but if you want to check whether a set is a proper subset, so there is no equality there, then of course you will have to use the operator. Okay, so I have given here examples of usage of these built-in functions as well as operators to check for whether a set is a subset of another one or a set is a proper subset of another one. So similar to the subset, we have the superset also. Again, if you want to check only if it is superset, you can use the operator also or the built-in function. But if you want to check whether it's a proper superset, you must use the operator. Okay, so that is what is noted here. And I have sample code to show you how it works. For you to have a better understanding of all these functionalities that I discussed, I have some exercises for you to try out. It's very important to try these exercises. So this is basically because we are looking at these data structures and the functions we have available to perform on these data structures from the perspective of problem solving. Exercise is actually a problem solving exercise. So you are required to write a Python program to implement COVID-19 contact tracing. So what you have to do, I am showing as the interface. Okay, so basically this is what you would have. This is what you would print to the screen. Okay, this is a contact tracing app, and it will say enter requested information and end by giving your name as end. So this is telling how you give input. So when you run this program, your contact tracing app, initially it will show this set of instructions. Then it will print your name. Then you type your name, and then you type your contact's name and the time spent with the contact, and like that. So once you enter this data, it will print this statement. Okay, and then you can keep on adding this data. Okay, this is how people will add data to the system. And once you have finished adding data, you can type end as the name. When you type end as the name, system knows, okay, you are done with data entry. So this is the introduction screen. Then you have the data entry part. Yeah, actually ending here. and then it will give you this output. This is the output part. Okay. So if you give a name of a person, it will say that who are the people who have been. So this basically this is how you build a database. If you are running this, of course you'll have to keep on adding data all the time, because I'm not storing it into a file and reading from file. But idea is that you can do this simple contract tracing by storing the data into a big database. And whenever you give a name of a person, it will tell you who are the persons that were in contact with that person and must self-isolate. Okay, so that's the whole idea. Okay. So I just explained to you the requirement by showing you the output screen. And this is how you should implement it. Okay. So you should use a list of tuples to build the database. Okay. And strings will be used to store the names of people. So I have now that output I showed you is from my sample program, which is about 50 lines of Python code with comments and everything. So it is not a big program or a complex program. So I'm giving you this number just to indicate you the workload. Okay. So yeah, so this 50 line is through a lot of comments also. Then I have another exercise for you. This exercise has some background which I am giving you. Legendre conjecture. So this is a mathematician, a French mathematician who has made seminal contributions to the field of mathematics. So as engineers, whatever you have feel, you will learn these mathematical concepts when you follow the course. Every discipline takes significant amount of mathematics modules every semester, until I think semester 1, 2, 3, 4, 5, and then in the final semester, semester 8. So these the concepts introduced by Legendre is used in many different areas of engineering, so there was a well-known conference that was organized in 1912 by another mathematician called Landau, and in that I think about 20 or so problems were presented, which many of them remaining unsolved to date. Okay, so that this Legendre's conjecture is one such problem. Okay, so read this carefully to figure out what the conjecture is. Conjecture is some hypothesis you say without giving a proof. Okay, so basically Legendre's conjecture says that if you are given a positive integer n, say 2, okay, between square of that number, so that would be 4. So if I give you n equals 2, it will be 4, and square of that number and square of n plus 1, so that would be n plus 1 is 3, squared is 9. Between 4 and 9, there will be at least one prime number. As you know, between 4 and 9, you have the prime number 5 and 7. Okay, so similarly, if you take any other number, say 4, square root of that is 16, and 4 plus 1, 5, square root of that is 25, and between that, of course, we have 19 and 23, which are prime numbers. Okay, so that's basically the idea here, but we don't have proof actually. So we can test, but we don't have proof. So that's why it's a conjecture. Okay. So my exercise to you is to implement some of these functions. Okay. So write a function. So when you are given a number n, check whether it is an is a prime number. So you are required to write this function is prime. Okay. Then if you are given a number, return a set of integers. So this one return. So this particular function will return a Boolean value, true or false. This one will return a set. Okay, set, because once you give n, it will return a set of integers which are primes between the range n squared to n plus 1 squared. Okay. Then write another function called legendary conjecture that returns the number of primes in this range. Okay. So yeah, so the whole idea is that you write this function using the other two functions. So essentially, what I would like to do is like, call the legendary conjecture with a number, say 100, and then you say for the number 100, legendary conjecture is true or false. So that's the exercise for you to try out. So that ends this part of the discussion. We still have two more data structures to discuss, dictionary and the ADTs.